George Pólya's alphametic. You know the expression, he wrote the book? Well, when it comes to problem solving, that would be George Pólya. Pólya did a lot of really important mathematics. He was a major 20th century figure, but what we're concerned with here is the work he did in mathematical reasoning and mathematics education. The best known of his books on this subject is the classic How to Solve It, which is one of those volumes that anyone who has any interest in teaching mathematics or understanding mathematical reasoning really needs to take the time to look through carefully. In fact, I'd read it multiple times if you're really serious. He wrote a number of other books on the subject. The following puzzle comes from a book called Mathematical Discovery. This puzzle is an alphametic. If you recall, an alphametic is kind of the mathematics equivalent of a cryptogram. In a cryptogram, we replace a letter with another letter so that it forms a meaningful name or phrase or something like that. With an alphametic, we replace each letter with a digit 0 through 9. It has to be a unique correspondence. Each letter goes with one particular digit and vice versa. And when we've made the substitution, what was a collection of words becomes an equation. So, for example, the very famous one is send plus more is money. That if you make the right substitutions, you get two 4-digit numbers that add up to a 5-digit number. In this case, we're going to do a problem with exponents. Now, you might expect that since exponents are generally more difficult than adding, this problem would be more difficult than a traditional alphametic, but it's kind of the opposite. Here's the puzzle. He squared equals she. In other words, we have a 2-digit number. If we square it, we get a 3-digit number where the second 2 digits are the same as what you started with. It's always a good idea in these situations to try to bound the problem, try to come up with an upper and lower limit for how big it could be. That way, instead of worrying about all these different possibilities, we only have to worry about a small subset. For starters, we know that HE is greater than 9 because it's a 2-digit number. Now, how about the upper bound? Well, remember, when you square HE, you get SHE. That's a 3-digit number. Now, a lot of numbers, when you square them, a lot of 2-digit numbers, when you square them, you get a 4-digit number. So we're only interested in those that you square and get a 3-digit number. In other words, a number that's 1,000 or less. Well, the square root of 1,000 is just under 32, which means HE has got to be less than 32. If it was 32 or greater, then it would produce a 4-digit number when you squared it. Now we've made a lot of progress. We've gone from 10 through 99 to 10 through 31, which is definitely a move in the right direction. But let's see if we can narrow it down even further by looking at the letter or the digit E. Now we need to figure out what digits we could put in here. Well, this is something that when you square it, the same digit shows up in the ones place. It's sufficient for our purposes, at least for now, just to look at the first 10 squares and get an idea of what numbers will have this property. We'll talk, we won't probably go into this next part, but if you think about it, you'll see that if we can show this for the first 10, we've kind of shown it for any number with that digit in the ones place. So here are the first 10 squares. Now you'll notice 4 of them keep the same digit in the ones place, or the number you square shows up in the ones place. There's 1. 1 squared is 1. By the way, this might make you a little nervous when we talk about squaring 1, but if you squared 11, I believe is 121. I think that sounds right. So you would still have a 1 in the ones place. Anytime you square a number that is a 1 in the ones place, a 1 in the last space there, then your square will also have a 1 in that position. Then we have 5 squared is 25. 6 squared is 36, and 10 squared is 100. So once again, that means that 1, 5, 6, and 0 are the final digits that we need to look at. Well, we'd already said that we're looking for numbers between 9 and 32. And now we know we're looking for numbers that end in 1, 5, 6, or 0. Well, that gives us 11, 15, 16, 20, 21, 25, 26, 29, and 31. And if you square all of these, you will find that if you square 11, you'll get a number that ends in 1. If you square 15, you'll get a number that ends in 5. If you square 16, you'll get a number that ends in 6. If you square 20, you get a number that ends in 0, and so on and so forth. Now, we've got it down to 9 possibilities for HE. That's pretty good. Keep in mind, we started out with 10 through 99, and then we got it down to 10 through 31. And now we have it down to these 9. But we can narrow it down a little bit more. For starters, look at 11. Remember, for an alphametic HE, that's 2 different letters, so that's 2 different digits. But 11 is the same digit repeated twice, so we can rule that one out. Now, also the 20. 20 is a pretty easy number to square. 20 squared is 400. And 400 definitely does not work, so I'm going to eliminate that one. So now we're down to 7. 7 is a manageable number. We can go ahead and just run through either a calculator or pencil, or probably just in your head for most of these. You ought to be able to just square these. So now that we've got it down to a small number of possibilities, let's just run through them and keep going till we find the answer. So 15 squared is 225. That would be no. 16 squared is 256. That would be no. 21 squared is 441. That would be no. 25 squared is 625. That looks good. So that would mean that HE is 25 and SHE is 625. Now let's just step back and think about what we just did here. For starters, we bounded the number HE. In other words, we said it's got to be more than this and less than this. And this greatly reduced the amount of the problem, because without doing this, we'd have to consider numbers all the way up through 99. And this way, we only had to go to 31, which is a big improvement. But it gets better, because then we looked at the digit E, and we said, what, when we square it, will the ones digit remain the same? And we came up with 1, 5, 6, and 0. So now we had 4 possibilities for E, and when we combine these two, that took us down to 9 possibilities. So we started out 10 through 99. And then we were able to get it down to 9 possibilities. And then we were able to quickly eliminate a couple of those and get it down to 7. And by the time we got down to 7, that was a manageable number. So we were able to just run through and try each one of those until we got the answer. These are all very important problem-solving techniques. The idea of bounding it and finding conditions that would make it simpler and thinking through the problem. We hope you've enjoyed this. If you did, please let us know in the comments. And also like and subscribe to this YouTube channel or to our blog, You Do the Math, K through Calculus.